first course in fluid dynamics by Patterson. A really nice book. This is a very nice book on fluid dynamics, which I did not have the chance to work through completely, but it's I think there's everything in a way that I like. Yeah, the problems are really nice. The entire book is like really nicely physically done. Not too much math needed, which I really like. Is one of my favorite books, Thedna, Entropy, Order, Parameters, and Complexity. The book has a minimal theory, like seriously, the theory is only like 2 pages long, every single chapter, and then there's like multiple, see the exercise, see it, it's like 10 pages of theory, and then there's like 30 pages or 40 pages of exercises and exercise and all kinds of niche stuff. It's absolutely beautiful. It's absolutely nice. It's just a joy to work through, but it's very difficult. Of course, you need quite some maturity to be able to handle this kind of stuff. It should not be your first course, of course. Here's the book I usually recommend for complex analysis, Freitag and Busse. And it's nice because it starts with complex analysis and it ends with analytic number theory, elliptical modular form. It has a sequel, of course. There's a sequel to it, and a complex analysis 2, which I also have and which I might show later. But yeah, if you want a book for complex analysis, the first book, I think this is really the one you want to go with. It's the one I'd recommend. You see Elmore and Hilt, Physics of Waves, which is a very advanced book on waves. And it starts with string, then it goes to a drum, a vibrating membrane, it goes into light waves, it goes into electromagnetic waves, it goes into waves in a volume, in a solid, everything dealing with waves in all kinds of situations, basically. Here is a book on advanced quantum mechanics, but advanced quantum mechanics not in a theoretical point of view, but more in a point of view of applications. So there's a lot of applications here. There's a lot of yeah, it's very much a application-minded book. Relativistic quantum mechanics, transitions, dissipation, yeah. Here's another book I really like. It's Osgood, Lectures on a Fourier Transform Application. It's a very good book on Fourier theory. Very nice, very applied, very beautiful, and many exercises. Not too rigorous mathematically, but it really goes in depth in intuition and why we care about Fourier transforms in the first place. Fourier series, Fourier transforms, distributions, delta functions. It has everything. Here is a course in general relativity by Foster and Nightingale. Yeah, just a book on general relativity. From a yeah, it's a very nice perspective. I like more better though. Here I have Marshall Doux, Quantum Mechanics. It's a book that is a very advanced perspective on quantum mechanics. And I learned a lot from this book, but it's been really hard on me. This is definitely not a book you read for fun, because it's very hard to work through. Here we have one of the first non-physics books. It's the complete 454 book Apocrypha, which has the different Apocrypha, Judeo-Christian Apocrypha. Book of Enoch, everything. Definitely working through it at one point, not now though. A Manual of Greek Mathematics by Heath. So it's all about what Greek mathematics is and how to approach it. The Complete Works of Archimedes by Heath. So what Archimedes did and why he did it. Again, Heath. Here we have Greek Astronomy by Heath, which is what Greek astronomy is and what they did. Then we have here Modern Quantum Chemistry, which is all about predicting how the atom is going to behave and how to model the atom, basically. Then here, Statistical Mechanics by Hill. Statistical Mechanics, which is a follow-up to his previous book. Here we have a history book on logic, the history of philosophical and formal logic from Aristotle to Tarski. A very nice history, very short too. Here is Ovidius' Metamorphoses in Dutch though. You have one of Barry Simon's analysis books, starting with Real Analysis, or the first volume. I really love these books, but they have filled with typos. It's really sad. The Doctrine of Triangles, a history of modern trigonometry by Van Brummelen. So it's all about the modern history of trigonometry, and of spherical trigonometry in particular. Then here we have the predecessor to that book, The Mathematics of the Heaven and the Earth, the early history of trigonometry, which is the Greeks and the Arabs. Here we have another book on fluid mechanics, this time by Cohen and Kundu. It's also a very engineering kind of book, but it does everything with tensors. It does everything nicely too. Less physical than the other books, but still very nice. The Bayesian Choice, a book on the fundamentals of Bayesian statistics, basically. Then we have here Classical Dynamics by José and Saletan. A very advanced book on classical mechanics. It starts from scratch, from Newton's laws, but it goes into differential geometry really quickly. A very nice book to work through, but you already have to know classical mechanics. Here you have another book that Tulip recommended me. It's S. It's not an entropic novel, which is about a book which is there's a book in both the book and in the footnotes of the book. So there's two kind of different books. Electrodynamics, a modern geometric approach. This is geometric algebra. Geometric algebra in electrodynamics. I really like this book, but I did not have a chance to work through it yet. But you see, it's all geometric algebra coded. Then here we have Quantum Mechanics with Basic Field Theory by Desai. I did not like this book very much because I did not like the overly physical notation of this book, but it has some really nice topics. Here we have Quantum Theory for Mathematicians. If you want to know the math behind quantum mechanics, this is really the book that you will want to work through. It has a lot of quantum mechanics topics and the rigorous math, the spectral theorem, it's a harmonic oscillator. It does all the math behind these things, basically. Here we see Hiltz, a history of probability and statistics. So this is everything of probability before 1750. So it deals with Pascal, it deals with Bernoulli, it deals with De Moivre, Montmort, why they were interested in probability, and so on. Here we have another massive book. It's Macquarie, Physical Chemistry. And it's a book starting from quantum mechanics all the way to modeling atoms, all the way to statistical mechanics, spectroscopy, statistical mechanics, solid and surface chemistry. It's thousands of pages of physical chemistry, basically. Here we have Edwards' Galois theory, which is Galois theory done from a historical point of view. So they'll look at the original writings of Newton, of Galois, of Lagrange, and just look at why they did what they did, basically. Here is Adventures in Celestial Mechanics, which is a fun book on orbits of planets and everything to do with it. Three-body problem, elliptical orbits, parabolic orbits, very fun. Here we have the Foundation of Quantum Mechanics, which is like a mathematical book on quantum mechanics. He starts off with Lebesgue integration, function analysis, and eventually goes into the logic basically behind quantum mechanics. Then we have A History of Greek Mathematics by Heath, Volume 2. Here we have the Almagest, the big work by Ptolemy, and his models for the universe of the ancient Greeks, at least. This was the book that influenced Copernicus to make his heliocentric model. Then we have here Bell, a logic book, a very nice logic book. It has a lot of very fun topics. It has like recursion theory, model theory. It has non-standard analysis, intuitionistic theory, recursion theory. It's set theory too. It's very, very nice to read. It's one of my favorite books. It has like inline exercise and everything. Yeah, I like this book a lot. Here we see Classical Electromagnetic Radiation by Hield and Marion. Deals all with, so it's like a follow-up book on classical electrodynamics, and it deals all with electromagnetic radiation and everything to do with it. Here we have Thermodynamics and Statistical Mechanics by Schell. So it deals with both statistical and thermodynamics in the same way. Not my favorite book on a topic, but yeah, it's not bad. Here we have Diophantus, a study in the history of Greek algebra. So it's Heath's translation of Diophantus. And yeah, this is the book that Fermat read and eventually led to his last theorem. Here we have, of course, The Art of Computer Programming, the last volume, volume 4b. I hope the rest of the volumes are still coming out while he's still alive. Definitely willing and reading this one at some point, but yeah, it's going to be one hell of a read. Here we have Digital Signal Processing by McClellan and Schaefer and Yoder. This is where I learned digital signal processing from a very engineering point of view. And it was very fun to see how math and Fourier analysis all came together in signal processing, basically. Then let's go to some other books. So here we see Nastase. Nastase's quantum mechanics book, which is a graduate quantum mechanics book I'm working through. It's yeah, I don't like the notations of physics quantum mechanics books. Like, they're very alien to me, and I can't really read them very well. So that makes this book very challenging to begin with. Yeah, but it has a lot of topics that I'm really interested in. Then we have here Classical Field Theory by the same author, Nastase, which is all about yeah, the classical theory of fields, which is what comes before quantum field theory. So it's all fields like general relativity and classical field theory and electrodynamics. A quantum mechanics book by Bronsdon and Joachim. So it's a quantum mechanics book, basically. Here we have Groups and Symmetries from a very physical point of view by Cosman Schwarzbach. Deals with finite groups, deals with compact groups, topological groups. Then we have here Physics of Atoms and Molecules, by the same author, Bronsdon and Joachim, which is all about why atoms are the way they are and how they are built up, molecular structure, and everything. Musy Mathematics, on the mathematics of music.